Hello, this video summarizes the main points of a paper that looks at the issues that arise when using multiple autonomic systems together. The paper builds on previous work by the same authors and applies the findings to a Google Cloud Platform outage on June 2, 2019 by implementing a test environment to mimic the outage as closely as possible and applying their findings. The paper name is Automated Management of Collections of Autonomic Systems, and the authors are Thomas, David, and Bradley. It was presented at the first International Conference on Autonomic Computing and Self-Organizing Systems, ACSOS, which was between 17 and 21 August in 2020, which was supposed to be in Washington, D.C., but was done virtually due to the pandemic. So managing enterprise applications is becoming increasingly complex because cloud service providers are creating more autonomic offerings as part of their services. To manage all these services is important, but difficult because the autonomic behaviors can conflict in unforeseen ways. For example, an autoscaler and a patcher using a rolling restart approach, where the servers are taken offline for maintenance in batches, can conflict if these behaviors are not managed. In this case, the autoscaler may schedule more resources on the remaining servers even though the patch service will be back soon. These sort of problems can be dealt with manually at design time or mitigated during operation, but in both cases it is complex and error-prone because a mitigation plan forms a combinatorially large set of possibilities. This is still a problem because one of the largest enterprise companies, Google, had an outage on their Google Cloud Platform data plane on June 2, 2019 that lasted 4 hours. The services affected were well known and include YouTube.com, Gmail, G Suite, Nest, Snap, Discord, and Vimeo. The outage was due to a software defect and 2 misconfigurations. Google engineers had to even travel physically to the data center to prioritize diagnostic traffic. Since a large company like Google can misconfigure the autonomous systems in production, and cloud service providers keep adding autonomic options to their offerings, the management complexity is only likely to increase. Related work includes a subsumption approach, where a hierarchical control system is used, but this has limited scalability. Orchestration approaches have also been attempted, but they tend to have a narrow focus, which makes it difficult to improve global and local utility. The previous paper that this work is built on uses stochastic multiplayer game simulation to synthesize plans for a collection of autonomic systems. The main idea of this paper is to apply the results of the previous paper to the Google Cloud Platform outage by creating a test system using Google Cloud Platform to simulate the outage. They pose 2 research questions. The first one is, would our automated approach have improved the performance of the network control plane in conditions similar to what Google Cloud Platform experienced? And the second one is, will our automated approach scale sufficiently to meet the needs of an enterprise system similar to the one presented in the Google Cloud Platform case study? The paper uses Prism to implement the model. So this is better because it contributes, or than previous work, because it contributes an improved and more understandable formal representation of the approach and an expansion of its capabilities to include global knowledge in the management of collections of autonomic systems. It also provides a point of validation of the effectiveness and applicability of their automated approach. And the solution was implemented using Google Cloud Platform standard services. Their evaluation showed that the outage severity reduction was in fact reduced. 61.7% improvement of aggregate inverse utility is what they found, and they conclude they would have improved outage performance. In terms of scalability, they found that there was a 5.4% difference in the aggregated inverse utility So they concluded that their solution would scale sufficiently. I only have some very small critiques about the paper. The GCP outage did not have all the data available, so they tried to reproduce it as best as they could, but without Google telling them exactly how they architected everything. They may have got some things wrong, but that's hard to double check unless you work at Google. And the other small critique is that they built it on the Google Cloud Platform itself. Now, this is good because it's the same environment as the outage, but it is multi-tenant, which means that, in theory, their results might vary depending on who else is using the system and what's going on. But they did try to mitigate this by running all their experiments in a 3-hour window, so that the chance that other users of the cloud platform influence their results is lessened. Thank you for your attention.